Good morning, class. Hope you're all doing great. Hope you're all having a good day. Day one to class. This is Math 1342, Statistics Online for Spring 2021. Welcome. I am your instructor, Professor Villalobos, and let's get started, right? So, I'm going to cover some small things, right? Um, what to expect from the class, how to become successful, and that's right. So first off, let's read the chapters and the sections right prior to starting that week's homework, right? And this doesn't really have to be an in-depth read, right? Right. I don't expect you to be like to come out of this being experts or anything, right? Um, so if you were to skim, these sections, that's fine, right? What I want you to get from this is to get your feet wet, right? I want you to have an idea of what the section is going to be about, right? So look through the examples, right? As you're reading these sections, they always give you, a few examples, right? And try to follow along, right? Well, as you're reading, try to follow along, especially the computational part, right? The part with the numbers and having to solve for that, right? Go ahead and look at those. And like I said, slightly, not slightly, but as you're skimming through the textbook, right? Chapter one is going to be very different from the upcoming chapters. Chapter one has more definitions, right? This is going to be a very different class than we're kind of used to, right? It's a very specific class, uh, precise, right? Um, when it comes to your calculations. So, how what you should start doing this week, or if you already started that, that's great, right? Begin reading chapters one. All right, right. Chapter one. All we're going to be going over would be, let's see if it lets me, right? Would be sections 1.1 through 1.4. That's all we're going to be looking at for chapter one, right? So now that we got that out of the way, right? Um, oh yeah, going back to how to be successful. Ask questions, right? I took this class before, two different times, right? Two different levels, and at times it can get confusing, or at times it's probably unclear, right? As you're going through these lecture videos, take notes, right? Take notes. Pause the video as you'd like, right? So you can go ahead and catch up on your notes. Um, if you have a question, if something's not clear, please ask me. All right. I want you to send me an email, right? You can contact me through the student email. A lot of you have already replied. Thank you. Or through the D2L email. That's totally fine. Either one would work. Um, just please ask, all right? Because I've been there as a student, right? Um, Sometimes it's easier to ask a professor or a tutor and get your question answered in probably 30 minutes than trying to just get lost trying to figure out the answer, and that could sometimes take up to 4 to 6 hours, right? If you're just blindly trying to look for something, right? So please email me, right? I do not mind at all, right? So this is why I'm here. I'm here to answer all your questions to make sure you are successful. Um, I'm here for you. So please contact me at through email at any time. I'll get back to you as soon as possible, right? If for some reason, let's just say, hey, you're up at 3, 4 a.m. doing the homework, right? That's totally fine. Use a discussion board if you're stuck, right? If you're hoping someone else might be up, right? Probably doing the homework as well. Use the D2L discussion board, right? Um, what I want you to do, right, when it comes to this class is, let's just say you approach a problem. I what I expect from the discussion board is, hey, I try to approach this problem. I did steps A, B, and C, but I'm not quite sure what to do with step D. Or I don't remember the formula for part D. Right? That's what I'm looking. That's what you should be
asking, right? If it's something um, hey, here's a question, help me solve it. I don't know what to do. Right? That's not gonna cut it, right? What I would, right? I'm more than likely going to respond. Be a little bit more specific. Where exactly are you needing help at? Help. What in which part of the problem are you needing help in, right? So that covers that. Another great source, an excellent source, which is going to help you 24/7, right? Even on weekends, right? Um, use the Connect Math Solve It, the guided solution, or the show example. Um, I put them all there for you for scenarios like that, right? So please, if you're stuck, um, take advantage of those, right? Definitely take advantage of those. And I have given the questions unlimited attempts, right? So of course, right, if you're doing these and you're kind of sketchy, you're kind of getting the hang of the question, more than likely you're not going to retain that information, right? So another way to be successful is in the class is if you kind of get it, keep doing more, right? Because the more the merrier, right? The more the better. The more examples you do, the more you're going to get good at at that solving that problem. Become just become a great a better student overall, right? So if you do a problem and you kind of get it, hey, do another one, all right? How I would usually approach these is I would look at the lecture, I would go to class, I would look at the lecture, and I would take my notes. Right after already reading the book, right, I'm getting more familiar with the material, right? I'm getting more familiar with the material. What I would then do is I would approach the problem and be like, oh man, like I remember A and B, C and D steps, not really, E sort of, but I need to get, C and D first. So what I would do is I would look at the show example, right? And I would sit down and analyze and break down, right? That's a skill, right? To break down what they're doing, right? Read every line and find out what they're doing. And what helps is get a piece of paper, right? Get a piece of paper and solve it the way they are, right? On the show example, solve it the way they are, right? It's kind of like using training wheels, right? Let's get the gears going, right? Let's get those brain gears going, right? And once you do, and look at the bigger picture, say, hey, okay, I have an idea how I can apply that to the next problem, right? You can go ahead and try another, right? Show another example, and try doing it with the notes that you had, all right? Try doing it with the notes that you had, and then you'll find out, hey, I'm getting kind of better at this. And hopefully by the third, fourth, fifth, or sixth, it doesn't really matter. Try doing it without your notes, right? Try doing it without your notes, just off of what you have already learned, right? From the knowledge you have already attained, and you'll see, hey, I'm doing good. And before you know, you won't really need your notes, right? You won't really need your notes. So that's the advice I have for that. Take advantage of the Connect Math. When it comes to your grade, right? When it comes to your grade in Connect Math, right? You can go to Gradebook and you can see, the percent that you have. That grade will not sync in D2L if you do not use the Connect Math links provided to you in D2L, right? So what we should be doing every day is logging into right the D2L, and then go to the appropriate week where those assignments are at, and then use the Connect Math links there, and that there would sync um, the grade you have in Connect Math into D2L, right? If so, if you have any questions with that, go ahead and reach out. And let's just say that, right, you saw the lecture video, you discussed it with your classmates in the discussion board, you went through through the Connect Math show example options, and you still don't get it. That's fine, right? That's fine. If it's not making sense, what I recommend you to do is either Google it or YouTube it, right? Find a creator or a channel that provides a different explanation, and hopefully it clicks. And most of the time, it will, right? Again, I've been there, right? I've taken this math class at the university. And I was like, man, it doesn't make sense. I'm kind of lost. I'm kind of confused. But there's usually more than one way to explain something, right? I would just right. I would go to YouTube, click, how to find the median of this sample, right? And I would open, it's usually on the first page. I really usually don't go over the first page. And I would click, I would open, I would open probably like 3 to 5 tabs, right? And watch each one, right? Kind of, power watch each one, and you'll know, right? You'll know when there's when something makes sense, right? You'll just know, and that's like I said, that's what I recommend as well, right? In other words, they're great resources, right? YouTube, Google, they're great resources with great other professors and teachers, content creators that post material that's there for you, right? That's there for you. So okay. So going back to sections 1.1 through 1.4, this section is going to be more definitions, right? More definition based. This is something that you would have to do, sit down and write, take notes, or just write. What would probably help is flashcards, right? Flashcards. Um, flashcards are great, all right. Whether you want to use physical flashcards, cut pieces of paper up, or even use online flashcard websites, right? There's one I can't think of it from from the back of my head, but they're great ones out there, right? They're great ones out there. So, oh, and real quick, what to expect from the class? If you do the homeworks, right? If you do the homework assignments, you'll be ready for the test reviews. And if you're ready for the test reviews, you'll be ready for the tests. So there is a strong emphasis in doing your homeworks by the due date, right? There are no extensions to the due date. If it's due by 11:59, right, and you submitted 2 minutes later, I'm sorry, it's late, all right. So please keep track of your calendar, right? If it helps to get a planner, I think it does. Please get one, all right, and write and keep up with the due dates, and also check your email daily, right? Because if I need to contact you regarding either your homework or your tests or any important announcements, it's going to be through email, right? Through either D2L or your student email. So please, please, please check that daily. Now let's move forward, right? I think it's enough introduction, right? Let's move forward, right? So the sections, right? Sections 1.1, 1.4, right? When you get your book or the ebook, read it, skim it, take notes on the definitions, because it's all going to be based off of these sections, right? From this is the foundation that you need to know to move forward, right? Now to approach a few examples, right? A few examples from chapter one homework, right? We're going to be talking about discrete versus continuous, right? We're going to be talking about discrete versus continuous. When we're talking about discrete and continuous, right? We're referring to the data that's given to us, right? And discrete is going to refer as right here, right? Discrete is going to be something finite, something countable, something whole, right? Something precise, an integer, right? Something that you can count. Continuous is going to be something more specific, right? Something that is, in other words, not precise, something that's you cannot get a definite number out of it, right? So either fractions or decimals, right? And so in something continuous could be like weight, right? Weight, if I were to get on a scale, it could say, right, let's just say, I don't know, like 150, right? But that's not, I'm not exactly 150, right? It could be 150.12784, and that number goes on, right? It's just that there's limitations on the equipment that we have that doesn't give us a precise answer, all right? That doesn't give us a precise answer. So let's give a few examples, right? Let's have here example one, right? I have here example one. um, right? What I want to know is to determine whether the data that is given to me is discrete or continuous, right? Example one, the number of players in a team. Well, the numbers of players in a team, right? It could be a team of three, it could be a team of five, a team of 17, a team of 100. That's a finite number, right? It's either going to be three or it's either going to be five, right? It's not like 5.5 players or anything like that, right? So this here is going to be discrete, right? Second example, right? I have here length of a model train track, all right? Length of model train track. That's length, right? Remember, length and weight, volume. We really don't have the the specific. We don't have these tools that can give us a precise answer, right? Depending on the scale you use, it's always going to give us a different value. So this is going to be continuous, right? Example three, right? What do you think about that? Length of phone calls, right? Length of phone calls. Ooh, that's time, right? The unit here would be time. So again, that's like a measurement, right? That's precise measurement, all right? Because whenever you're thinking about time seconds, you can get very precise, right? You can get like milliseconds, deciseconds, nanoseconds, right? So it goes on, right? It goes on. So this here would be again continuous, right? Okay, you go to your printer, or right, you open a printer somewhere, and you see the number of ink cartridges in a printer, right? What do you think? You open the ink cartridge slot and you count the number of ink cartridges. That is going to be discrete. That's going to be discrete, right? So you see there's going to be none in there. It's probably going to be one or three or four, right? Right. It's going to be a solid value. And finally, right, for this example, height of basketball players, right? Height of basketball players. Ah, right. We're going back to the whole volume, right? We're going back to the whole thing: height, weight, time, right? We associate that with what? Continuous, right? We don't have the appropriate, the tools that we have aren't right. They're not that specific, right? That number is going to go on. So that is the part we're covering right now for discrete versus continuous. Go ahead and move on, right? The for chapter one, the only numerical parts, right, is going to be this section here, where you're going to be asked to give the boundaries of numbers, right? You're going to be given a number and you have to give a boundary for it, all right? So one thing to remember is if you see the number 4, we know technically that is 4.0, right? Right, that's 4.0. It wouldn't be 40, right? Because that would be 40, right? So things like that, right? Things to remember, right? So first example, right? Let's do example 1 here, right? We have 4 millimeters, right? We have 4 millimeters. To give the boundary, right? You're gonna have to give two boundaries. You're gonna have to give the upper boundary, right? Which is gonna be the number to the right, right? And you're gonna have to give the lower boundary, the lower number, right? To the left. And if you're saying, hey, left or right, what do you mean? Well, if you draw this on a number line, right, you're looking for a number to the right, and you're looking for the number to the left, all right? How you find the number to the right is you are going to add a 5 at the very end of the number. Pretty straightforward, right? So this here, it's going to be, is it going to be 45? No, right? It's going to be 4.5, all right? You're adding a 5 to the very end of the number, all right? So this means 4.5, right? And that makes sense, right? You're a little bit to the right, right? That's my upper boundary. How you find your lower boundary, right? So this is my upper boundary. And how you find your lower boundary is you're going to get the rightmost number. Right here, we only have, oh, let me go ahead and fix this real quick. How do we do this again? Oh, there we go. All right. Ooh. So this is my upper boundary, right? So the number we're going to be talking about here is 4, right? So to find the lower boundary, you get the number furthest to the right. Well, here it's just 4, right? That's all we have. It's just 4. And I need you to subtract 1 by it, right? So 4 minus 1 will give me what? 4 minus 1 will give me 3. And then what I need you to do is add that 5 to the far right, right? Very similar to what you did for the upper bound, all right? So here I'm going to add a 5. But I know I wasn't talking about 35, right? I was talking about 3. So adding something to the right will be a 3.5, right? Let's not forget that. And since that is my lower bound, that's going to be right there on my number line, right? Right, that's going to be right there. And, and you see that, right? It has from 4, if you add 0.5 to it, right, it gives me the upper bound. And if you subtract by 0.5, right, it gives me the lower bound, right? Let's give another example, right? Let's give another example. Go ahead and clear this. And by all means, pause the video if you have to, right? If you have to pause the video, that's fine. Okay, let's give 2.6, right? Something that already has the decimal there, right? Something that already has the decimal there. So again, to find my, let's do lower bound here and let's do upper bound here. I think that makes a little bit more sense, right? To find, I think that's more organized, a little bit much nicer. To find my upper bound, all I'm going to do is I'm going to add a 5 to the very end, right? To the very, very end. So there's a 6. All I'm going to do is attach a 5 to it. Hey, that's it, right? I found my upper bound. I attached a 5 to the very end, right? To find your lower bound, we said we are going to subtract 1 from the farthest most point, right? So here it's going to be that 6, right? I'm going to take a 1 away from that 6, right? Just from that 6, right? I'm going to get that 6 subtracted by 1, and that's going to give me a 2.5, right? And that 2.5, I'm going to attach a what to the very end? What am I going to attach to the very end of that? A 5 again, right? So then my lower bound is going to be 2.55, right? And one thing I just saw is make sure you subtract it from right here. Make sure you subtract the 1 from the 6 and not a 2.6 minus 1, right? Because that's going to give you something very different, right? So all you're really focused on is the last value, right? Not the whole number, just the last value, right? So if I were to put this on the number line, this is 2.6, this is 2.65, and this is 2.55, right? And you notice that the distance between these two is 0.05, right? And the same thing is here. The distance between those two is 0.05, right? Let's give another example, right? Let's give another example. Let's do example 3, right? Let's do example 3. Have 179. Ooh, it's a whole number. That's fine, right? We got this upper bound, right? And we said this is lower bound. I think that looks nicer. So to 179, right, I'm going to attach a 5 to the very end, right, to the very, very end. But I know it's not going to be 1795, right? Since I was talking about 179, I know that technically was 179.5, right? Pretty straightforward. So we notice with the whole numbers, you're going to have to apply that decimal yourself. So be on the lookout for that whenever you're dealing with whole numbers, with integers, right? Okay, and we said to find the lower bound, I'm going to subtract 1 from the farthest most number, right? So that there is going to be 9. 9 minus 1 is going to give me 178, right? I'm sorry, yeah, uh, 9 minus 1 is going to give me 8. So that technically there is, all right, 178. And again, I'm going to attach a 5 at the end, right? A 5 at the end. But I know this has to be 178.5, right? Okay. And the last example I have here is going to be 4.03, right? Let's give here the, what we say, upper bound and the lower bound, all right? So for the upper bound, again, it really doesn't matter. What all I'm going to do is add a 5 to the very, very, very end, 4.035, right? And what do you think we have to do with the lower bound, right? Same thing we've been doing, right? Same thing we've been doing is you're going to subtract a 1 from the farthest right number, which would be what? 4? Would it be the 0 or would it be the 3? Yes, it's going to be the 3, right? So 3 minus 1, that's going to give me 2, right? So I'm going to write 4.02. And then I'm going to add a 5 to the very end. So that's going to be 4.025. So those are my bounds, right? My lower bound will be 4.025, and my upper bound would be 4.035. Okay, and right now we're going to be moving forward towards measurement scales, right? A nominal, ordinal, interval, and ratio levels, right? Um, and there's a nice little table that's provided for you, right? This is going to be section 1-2 or 1.2. Specifically, it's going to be page 9 in table 1-2, right? And I have it here, right, on the right hand side, right? So please, whenever you're doing your homework, if it helps, definitely, right, pull that part of your ebook, right, or take a picture of it from your phone, or pull it up on your physical copy of the book, right? Right, and here it shows you, right? We should have already read this part where we get to differentiate nominal level data, ordinal level data, interval level data, and ratio level data, right? Um, so for our example one, whenever it comes to money, whenever you're asked about, it's you would be specifically they would ask you to classify the variable as either a normal level, an ordinal level, an interval level, or ratio level measurement, right? So whenever you see this, what helps me is if you're looking at anything with money, right? Salary, something with price or cost, right? Like for example, one, movie ticket prices, right? That's going to be a ratio, right? So this here will always be a ratio. So always be on the lookout for that money, right? Money's good, right? Money is going to help us out. So whenever you see anything associated with money, go to ratio level, and you see that here, right? Salary, or you can find dollar signs, right? That's supposed to be that's bad, but that's supposed to be a dollar sign, right? And you see other examples here, right? Age, weight, height, and time, right? Um, Furniture types, right? So you're asked to classify the variable as which of these, right? So furniture types, right? There are different types of furniture, right? There's probably right artistic ones, bulky ones, soft ones. There's a you have a variation for these, right? There's different types you can get, right? So this here would be something like colors on a car, right? It's like if you were to go to IKEA, right? You can get different colors for a certain couch, right? So this here would be nominal, right? This here will be a nominal, right? Another example would be sizes in a pizza, right? Oh, I love pizza, right? You can get small, medium, large, extra large, right? Or again, another example would right, and the example I gave there, right? That's also in your textbook, right, on page 9, right? So different sizes, right? We're talking about variation in sizes, right? The options that you have. Another example would be fast food restaurant drink sizes, right? Do you want a small, a medium, a large, right? That there would be ordinal, right? That's going to be ordinal. And you see other examples. other examples of ordinal, right? You could say the grades that you're able to receive in this class, right? Classify the variables as the grade you're able to receive in this class. Well, that can only be A, B, C, D, or F, right? Those are your options there, right? And of course, right, you see other examples, right? So let's read through these. Let's go ahead and make sure we're familiar with these, right? Go ahead and move on to the next section, right? This here would be page. Go there. This here would be figure 1-3. Specifically, this is page 15, right? Page 15. There's another little data chart, right? There's another little data chart, right? And here we're talking about data collection, right? Others, sampling methods for we got the random method, we got a systematic method, a stratified method, and a cluster method, right? And it all depends, right? It all depends the population that we're looking at, right? And what do we get from those samples, right? So for example, here we have every 10th phone customer was asked to remain on the line to complete a satisfaction survey, right? So this is organized, right? It's going to be like the 10th number, the 10th customer, the 20th customer, the 30th customer, then the 40th, the 50th, right? So you can say something like K10, right? 10K, right? Where K is 1, 2, 3, and so forth, right? So if K equals 1, right, this is 10 times 1, which is 10. So that's going to be the 10th customer. If K equals 2, this would be 10 times 2. This would be the 20th customer. And if K equals 3, and so forth, right? You'll see this 30, 40, right? So there's a system. And that makes sense, right? Hey, well, what is it, right? This is a system. There's a formula for this, right? This here, as you may already have guessed, this is systematic, right? And if you look at the graph, it shows a beautiful interpretation, right? It shows what do you think, right? If you notice on page 15, you're giving the population, right? And what do you extract from that population, right? You see these bottles, right? You see a 3, a 6, a 9, a 12, a 15. That means by every threes, right? Every threes, that's going to be the sample you're looking at, right? So that's going to be systematic, right? Another example would be students in an automotive class were selected by their ID number using a random number generator and then asked their preference in brand of tools. Preference in brand tools, right? And you might already have guessed this is the keyword you're looking for, right? That's the keyword you're looking for. So the data collection method here would be random, right? Random, right? It's just random. So and there are two other ones, all right? And I'll let you go ahead and read the section and then attempt the homework problem so you can go ahead and see the difference between stratified and cluster as well. Let's go ahead and move on to experimental versus observational, right? And last, right, this is going to be 1-2, 1-4. The types of studies that are being applied, right? So the types of studies that are being applied, if you look at your textbook on page 18, right? That's where page 18, right? So there are several different ways to classify statistical data, right? Statistical studies, right? And here we're going to be talking about two types, which is going to be observational studies and experimental studies. How I like to approach this is observational, right? Observation is going to be, imagine you're not really interfering, you're just sitting down, you're just backing up, and you're like looking. That's all you're doing. All you're doing is observing. You're not intervening. You're not giving them anything. They don't have instructions to do stuff. You're not gonna collect data. Oh well, you're gonna collect data, right? But it's gonna be based on just observation, right? Based on observation. And how you might already guess the other one, experimental studies, right? That's going to be a task is going to be given, right? You could randomly select individuals and you're giving them things, right? And they have a task, and then you're going to gather that data and give a conclusion. Um, so those are the two different types, right? So example one, right? Determine whether an observational study or an experimental study is being used. A study using college a study using college students was conducted to see if the percentage of males who pay for a date was equal to the percentage of females who pay for a date. And ask yourself, were the males and females given anything? Were they given a task? Or was this pretty much done just through observation? What do you think? Yeah, by observation, right? There was no task given. All you did is you selected a few students and you just, all you did was sit back and observed, right? So this here would be an observation, right? Example two, three groups of gamblers were randomly selected. The first group was given $25 in casino money. The second group was given $25 in coupon for food. And the third group was given nothing. After a trip to the casino, each group was surveyed and asked their opinion of their casino experience. So you as a scientist, what did you do? Did you give them a task? Did you give them set of rules? Or did you just sit back and you watched? Ah, you didn't, right? You didn't sit back and watch. You gave them money, right? There was right. There were specific things you gave everybody. So this here would be, in other words, you conducted an experiment. This is experimental. Okay. And last example, two groups of factory workers were randomly selected. The individuals in group one worked the night shift. Group two individuals worked during the day. At the end of the 6 months, each group was surveyed about job satisfaction. Right? This one might be a little bit tricky. You might think it's a little bit tricky, but again, read it again, right? Did you give them a task? Did you give them anything? Were you running an experiment? Or did you just sit back for a longer period of time and just observed? Yeah, you observed, right? This was an observation. You sat back and you made an observation, right? It could sure it was a little bit longer than the first one, right? Than the first example, right? 6 months, right? But at the end of the day, again, you didn't. It wasn't like example two, right? You didn't give them tasks, or you didn't give them money, or you didn't conduct the experiment. So those are the two different types. So this is going to conduct the lesson for chapter one, right? Again, it covered sections 1.1 through 1.4. If you have any questions or concerns, please send me an email, right? Contact me. And I should be posting the video for 2.1 shortly. So thank you very much. Enjoy the rest of your day and happy studying.